In 5.4b, we're going to look at z-scores. So, all situations and examples will take the assumption that a normal model is followed. If we knew that the mean score on the biology test was 87, so here's a little example. We knew that the mean score on a biology test was 87, so this is our mu, our mean, and the standard deviation was 4. A student who scored a 91 on the test would be exactly blank standard deviations blank, the mean. So let's look. 91 is 4 above 87. So 4 is a standard deviation, so that's 1 standard deviation above the mean. And his or her z-score would be positive 1 because it's 1 away from the mean. So that's what his z-score is. But what about a student who got a 97? Now, why is this different? Well, 97, 87 plus 4 is 91 plus 4 is 95 plus 4 is 99. 99 is 3 away, so what's going to be 97? What would that z-score be? How many standard deviations away? So we use this little formula to calculate it. Again, z-score, how many standard deviations away from mean? The z is for z-score. X is your data point. Mu is your mean. Sigma is your standard deviation. So, our score is 97. Our mean is 87. And our standard deviation is 4. So I get 10 over 4, which is 2.5. If it's positive, then we're above. And if it's negative, we're below. And so how would I interpret this? The score is 2.5 standard deviations above the mean. All right, let's look at the next one. Using the same information as above, calculate and interpret the z-score of a student who scored an 80 on the test. So go ahead and try that. So again, mu is 87, sigma 4, and our data is 80. Got negative 1.75. The score is 1.75. Standard deviations below, because we're negative, the mean. Let's compare this to what we learned in 5.4a. So in 5.4a, we had our curve. And so if our mean is 87, I'm adding by 4, and then subtracting 4, Okay, so 80 is right here. And look, this is about 1 3/4 away from the standard deviation. Let's look at the other one. This other one was 97. 97 is right here. So from the mean, we're 1, 2.5 away from the mean. So that's what our z-score is telling us. All right, let's look at this next question. A Colorado ski resort and a Lake Tahoe ski resort each had a successful Christmas, New Year's holiday period due to the fact that there was an abundance of snow. The Colorado resort reported 88 inches of snow, while the Lake Tahoe ski resort reported 74 inches of snow. The average and standard deviation of each resort during this period follows. So here we have our averages and our standard deviations. Relatively speaking, which resort had more snow during the Christmas, New Year's holiday period? Okay. So in this paragraph, there was an important number. Colorado was 88 inches. And then Tahoe was 74 inches. So our data, Colorado was 88, Tahoe was 74. So which one had more snow, relatively speaking? This means that we're relating it to the mean. So for Colorado, our data is 88, the mean is 78, and the standard deviation is 8. So I got a z-score of 1.25. For Lake Tahoe, the data is 60. I'm sorry, the data is not 60, the average is 60. The data is 74, the average is 60, and the standard deviation is 10. This is 14 over 10, this is 1.4. So, relatively speaking, which one had more snow? Well, compared to the median, compared to the mean, this one's farther away. So we're going to say Lake Tahoe. Since the z-score is higher, the data is farther from the mean. For this next example, we have a neighborhood where the size of the average house is 2,100 square feet with a standard deviation of 80 square feet. What is the size of the house, which has a z-score of 1.3? So let's read through this again and label everything. 2,100 is our average, so that's our mu. Our standard deviation is 80. What is the size of the house? So we're trying to find our x with a z-score of 1.3. Let's plug this all into our formula. Z-score, remember our formula is z equals x minus mu divided by sigma. So our z-score equals x, we don't know what x is, Our average is 2100. And our standard deviation is 80. Now we have to solve for x. So we're going to times by 80. I get 104 equals x minus 2100. Add the 2100. And I get x equals 2204 square feet. All right, go ahead and try this next one where the z-score is negative 2.1. So this time our z-score is negative 2.1. And we don't know the data, but we do know the mean and the standard deviation. So we times by 80. So I get negative 168 equals x minus 2100. Add 2100. X equals 1932. So 1932 square. For our last example, we're looking at the size of trout in Sierra Nevada lakes. So we have a trout that is 7.2 inches long and a z-score of negative 1.5. And then I have a trout that's 12.12 inches long and has a z-score of 2.6. What is the mean and standard deviation? Since they're telling us that it's a normal model, we know that we can use a bell curve and think of a bell curve. So we're going to say that's where my mean is. This one is negative 1.5 away. And that data point 72. This one's 2.6 away. And that's 12.12. So we need to find sigma first. Find our standard deviation. And we do this by saying, okay, this distance is this distance times our standard deviation. So 12.12 to 7.2 is the distance between my z-scores times my standard deviation. This is 4.92 equals 4.1 sigma. We're going to divide by 4.1. And I get sigma equals 1.2. That's my standard deviation. Next, we're going to find the mean. And we're going to do this by pick one data piece. So I'm going to pick trout 1. Trout 1 is 7.2 inches long and has a negative 1.5 z-score. So my negative 1.5 z-score is 7.2 minus mu over, and my standard deviation is 1.2. So we times by 1.2. I get negative 1.8 equals 7.2 minus mu minus 7.2 negative 9 equals negative mu, so mu equals 9. So my mean is 9. So again, we first had to find the standard deviation by thinking about how this distance is this distance times the number of standard deviations. And then I found my mean by working backwards from my z-score formula.